This is session 6F. It'll be a half-hour session. And the speaker today is Dr. Natali Becker. The topic is strategic use of smart factory concepts for flexible and hybrid learning for engineering students in the field of automation technology. Dr. Becker is at the University of Siegen, is that the concept? Chair of the Technical Vocational Didactics in Siegen, Germany.
Thank you. Hello. My name is Natali Becker. I work as a research assistant at the University of Siegen, Chair for Technical Vocation Didactics. Today I am presenting my research of the subject of strategic use of smart factory concepts for flexible and hybrid learning for engineering students in the field of automatization technology. Yes. Universal digitalization depicts most spheres of life when technologies and services of the global internet network get increasingly involved in everyday life. To face such change in the modern world and transformation process as sustainability, digitalization, artificial intelligence, heterogeneity, inclusions, the formation of new concepts and paradigms affected not only the scientific and production sphere, but also specific areas of human existence is inevitable. Today, the word community.
I'm so sorry.
Yeah.
I think your slide is frozen. Do you want to reshare again for your presentations?
Oh, yes.
No worries, no worries.
Good.
I think still on the first slide, and it's not working now. Do you want to stop sharing and reshare again?
Good. Oops.
I think now is for agenda. Yes, and. And you can put your presentation before screen. So now is the first slide. Is that correct?
Yes.
Do you want to use in the presentation mode? But because now I can saw your like the PowerPoint, all the things in this kind of the screen.
Okay.
No worries. Now is second one. Is that correct? Yes, you can continue.
Good. Yes. Yeah, in engineering education, complex knowledge or technical respectively problem-solving skills development should be combined with creativity and sustainability aspects such as resource efficient in order to face future challenge. Thus, technical development and the correlating process should not only focus on functionality and efficiency, but also on environmental and social compatibility. This multi-perspective competence development depends on self-reflections, analytical and creative thinking, with pauses, higher equipment on learning process. Additionally, the heterogeneous pre-knowledge of students has to be taken into account in evolving individual learning paths. Yes. The fifth industrial revolutions has been advancing since the beginning of the 20th century, heralding the convergence of the digital, physical, and virtual realms through the interplay of emerging technologies such as IoT, cyber-physical systems, cloud computing, big data analytics, adaptive robotics, artificial intelligence, additive manufacturations, and virtual and equipment reality. The cloud be described as a revolutionary transformation driven by a diversity of recent technologies. Unlike previous revolutions, the emerging technologies and innovations are spreading much faster and more extensively. One of the effects of Industry 4 is complex factory automation enabled by the extensive use of these new technologies, which allow for highly advanced configurations of automation productions. Industry 4.0 in the digitalization of productions. The aim is to make the real world with the virtual world. We can hear then using state-of-the-art digital information and communications technology. The aim is to create intelligent networking between people, machines, and industrial process. Here you can see new industry technologies as autonomous communications of products or machine elements with high-level control systems via radio frequency identifications, RFID, near-field communications, and QR code. The automatic processing of data using enterprise resource planning, manufacturing execution systems, and supervisory control and data equations. Also, adaptive manufacturing technologies as 3D printing, glass sintering, intelligent materials, and collaborative robotics. Cyber physical system consists of a basic highly integrated mechanical systems combined with complex actuator and sensor systems. Information, energy, and material input flows are processed and changed to different information, energy, and material output flows. Inside the systems, the information process can be designed in non-cognitive och de respektive sätts associative och cognitive manner. The latter enable an intelligent system control. Informationsprocesses are provided by embedded systems and also connected to additional cyber-physical system through different communication systems. Cyber-physical system, simply interactive cyber-physical systems can be used in different contexts and depict a flexible production system with partly intelligent production control. Cyber-physical lab from Festa is complex smart factory topics and can be used as a basic from practical training in mechatronics, automatization technology, and smart factory technologies. Interactive cyber-physical. The first cyber-physical lab depicts an interactive learning systems that consist of 6 applications models. In order to produce a prototype smartphone. As it can be seen, the cyber-physical production systems consist of 6 applications model, model high-pay, model eye-drilling, applikationsmodell magazin, model muskelpress und turning. And a bridge for the transformation robot, Robotino. All application modules are connected with a transfer systems moving the product parts with a carrier and pallet. With a RFID chips where actual product and production data can be read and stored. The overall production control concept is realized with manufacturing execution systems and in combination with the PLC control to start production orders in a self-organization manner. The learning strategy should be realized using project-oriented and scenario-based learning methods. A learning tool, the Festa Cyber-Physical Lab, and augmented reality, virtual reality, simulations und Metaverse building learning by doing. Let us take a closer look at the different forms immersive learning might take. It is used individual learning patch can be integrated into a learning management systems. Here you can see it equipment reality AR with real VR glasses. Here can you see virtual reality Arbeit. Simulation are also digital environments that mimic real environments. Here, using the manufacturing execution systems und robotic sim für Rabatina, from Rabatina. Für, a metaverse is a digital twin of a physical space. Here can you see zeros? As a basis for competence assessments, the holistic approach of shaping competence is used, including the following criteria of COMET model. Presentation, functionality, use value orientations, efficient work and business process orientations, social compatibility, environmental compatibility, and creativity. The learning scenarios are tested in different contexts in order to gain a great variety and understanding of the individual learning needs. Learning scenario Optimisation of technologischen Prozess, Produktionsprozess. Customer-specific products have to be integrated in the production process. Therefore, the MES systems has to be adapted. This requires complex knowledge about the manufacturing execution systems in combination with PLC that can be assisted by distance support. Via an equipment reality glass. Adaptational learning videos can be easily made with the AR glass. Also, change and variations of production process or different solutions can be documented. It can be seen that the manufacturing execution systems should be developed in a flexible manner so that all production process configurations can be realized and supported. Both learning scenarios are tested and assessed by different groups using the criteria for the competence commit. The result not only confirm existing theoretical frameworks, but also point to areas that require further investigation and refinement. The implications of the result suggest towards more personalized, adaptive, and sustainable learning environments, reflecting broad trends and education theory and practice. Here can you see learning scenarios 1 and learning scenarios 2. Adaptations of the manufacturing execution system and RFID systems, so the different cloned smartphone case can be produced in parallel. In our opinion, The joint application of different education technologies in the learning process can bring a significant synergetic effect. Modular concept at various qualifications levels, incorporating the individualizations of products and the associated flexibilizations of Produktionsprozess. Use of cyberphysische System AR und VR as a learning medium in combinations with project orientations and PBL elements for reflective and independent learning, individual choice of topics during resultations enables interdisciplinary work and provides additional motivation. Holistic view of the technical systems, including the technical physical fundamental and visualizations of the interactions between subsystems and overall functionality. Digital support for the learning units is currently being implemented. The implementation of smart factory concepts for flexible and hybrid learning for engineering studies in the field of automation technology has a number of aspects that need to be taken into account and worked out in the course of improving the methods of technology implementation. Hybrid learning is focused on learning satisfactions and access to education. The amalgamate consolidation of previous knowledge context in the field of automation targets that future development of this approach in the form of the inherent interdisciplinarity module should be considered. The integrations of additional teaching tools such as chatbots and AI technology should also be the subject of future research endeavors. Yeah, thank you.
Thank you so much. And if anyone have any questions, please share in our chat, and we will have more the comments.